Welcome to our next video. Now today we discuss some examples on Laplace transform. In my previous video you see all the properties and what is a Laplace transform, what is the value of this Laplace transform in integral form, and what is the parameter we will transfer from t parameter to we have to transfer in s parameter. So how we solve this Laplace transform? Question is, if ft is sine 2t for 0 to pi and greater than pi, function value is 0. So how we solve these types of, if break of limit questions are given, if total limit 0 to infinity, then we directly apply the formula of Laplace transform of sine 2t. But in this case we have to solve it with the help of basic definition. So Laplace transform of ft is equal to 0 to infinity e to the power minus of st ft dt. Clear? So we have to substitute at the place of ft, we have to substitute our function, but function have 0 to 2 pi value, 0 to pi value, function have value sine 2t and greater than all value is 0. So with the help of ft, this integral for above pi to infinity goes 0. So our value of this function is given by this. Now again simplify it, we have to apply e to the power ax sine bx formula, apply the limit, we will get the solution, and our solution what we get is 1 by s square plus 4 2 e to the power minus s pi minus of 2. When you apply the limit after integration, you will get this term. This is the required solution for given function. This is the required Laplace transform of given function. Next, very simple. If you know all the formula about the Laplace transform and you go step by step, then you can easily solve. So you have to remember all Laplace transform of t to the power n, Laplace transform of sine at, cos at, sine hyperbolic at, cos hyperbolic at. These are the basic transform and with all properties. Now if we have to find out, function is cos square kt. Find the Laplace transform. So Laplace transform of cos square kt we cannot do directly, but we using one trigonometrical formula, cos of square t is equal to 1 plus cos 2t by 2. So we break this 1 plus cos of 2 kt by 2. Clear? Now we apply the Laplace transform. 1 by 2 is constant, taking outside. First term is Laplace transform of 1 plus Laplace transform of cos 2kt, cos t and 2k. Means a is our cos at, a is our 2k. Clear? So now what is Laplace transform of 1 is 1 by s, you should remember. So this is 1 by s plus Laplace transform of cos at is s upon s square plus a square. My previous video you can see. So s upon s square plus a is 2k square, that is 4k square. So this is the required solution for given function. Similarly we can find out the sine square kt. So definitely square, first you remove the square and then you apply the transform. Next, one more example. If function is 3t to the power 4 minus 2t cube minus 4 e to the power 3t minus 2 sine 5t plus 3 cos of 2t. Find the Laplace transform of this function. Now here we using linearity property, we can take each term individually Laplace transform taking constant outside. So Laplace transform of ft is given by 3 Laplace of t to the power 4 minus 2 Laplace of t to the power q minus 4 Laplace of e to the power minus 3t minus 2 Laplace of sine 5t plus 3 Laplace of cos 2t. Now if you know the formula, you remember the formula, you apply one by one. 3 t to the power n. What is the formula? Laplace of t to the power n, factorial n upon s to the power n plus 1. N is our 4. So Laplace is factorial 4 upon s to the power 4 plus 1 is 5. Minus 2 t cube given, factorial 3 upon t to the power 4 minus 4 e to the power at is 1 upon s minus a. So e to the power minus at is 1 upon s minus of minus 3 is s plus 3. S plus 3. Next sin 5t. So minus 2 a is 5 upon s square plus 5 square is 25 plus 3 s upon s square plus a is 2. So 2 square is 4. So this is the Laplace transform of given function. You just multiply the constant and simplify it, you will get the required solution. So Laplace transform is very easy if you go step by step. So these are the some examples of linearity property. Next we go for first shifting property. First shifting property is what? If any exponential function multiplied with our Laplace transform. So if we have e to the power 5t sine hyperbolic, or we can say e to the power 5t t to the power 5. Clear? So how we go Laplace transform of this? This is example of first shifting property. So Laplace transform of this, first we have to find out Laplace transform of t to the power 5. So t to the power 5 is t to the power n is factorial n upon s to the power n plus 1. So factorial n is factorial 5 upon s to the power 5 plus 1, 6. Now what is our first shifting property? First shifting property state e to the power at ft is Laplace transform when we f bar s minus of a. S replace with s, if s replace with, so when you use this property you have to write the statement that next we have to using first shifting property. Statement is if any exponential function multiply with this, then answer is this, s replace with s minus a. A is 5. So our Laplace transform of e to the power 5t t to the power 5 is given by factorial 5 upon s minus a is 5 to the power 6 is the required solution. Clear? So how we use first shifting property? Similarly, first shifting property with sine, with exponential function itself, and many more. Means anywhere if e to the power multiply, you can use this first shifting property for solving this question. That's all for today. In my next lecture, you can see some more example on more property. Thank you very much.